Good afternoon, everybody, or good morning, depending on where you are. My name is Antonello Monti, and together with my colleague Markus Mirz, I'm going to present you the SOGNO project, which is one of the new projects in the Linux Foundation Energy family. SOGNO stands for Service-Based Open Source Grid Automation Platform for Network Operator. First of all, I would like to start giving you a bit of background how this project was developed. Most of the work came from a European project in Horizon 2020 program where the technology was developed. The original idea came in the project. It was exactly called SOGNO, like the platform, in which we cooperated with several partners. In particular, we means RWTH Aachen, in particular with Ericsson, there was the coordinator. And we approached the problem on how to structure a platform for grid operation with focus on distribution grid that was able to fulfill the requirements that are determined by the new characteristics of the power system. We can summarize these new characteristics in saying that things are moving at the edge and the focus is moving at the edge. This is mostly due to the increase in penetration of renewable energy sources, is given by the active role of customers. And this is bringing a completely new view on how the grid should be controlled and operated. In the project, we're also looking at how artificial intelligence services could support, but a big part of the project was really understanding the architecture of such a platform that then became the SOGNO platform. And the result is here summarized, and this is the architecture also of the SOGNO platform as a Linux Foundation Energy project. You see at the bottom the components, the real hardware. In the middle, we have the communication. In the project, originally focusing on 5G as the most interesting options of connection that brings directly the possibility of edge cloud, but also other communication links are compatible, let's say. We support a variety of standards for data management. Key element is a message broker architecture, and then the definition of services which are implemented as a microservice. The message broker in the original was MQTT. We are now looking at the possibility also and implementing also Kafka version. And then each of the services are here microservice that bring a modular approach. And this is key element of building automation for grid as a modular solution, where modular elements are typically different type of services. In this case, in the project, focus on state estimation, on fault location identification and system restoration, or also in load forecasting, generation forecasting. And on top of the service, then we have the overall data management service, so linked to data platform, and user interface, so link again to standard man-machine interface type of services to build a kind of grid dashboard. What is interesting is also that the architecture can be seen in two different versions, as fully centralized, running in the control center, so in a private cloud, for example, in the control center, or to fulfill this edge type of solutions, we can also imagine a hierarchical structure in which several instances of the platform are running on the edge, particularly fitting in the edge architecture of the 5G network, but not necessary, as already said. And then a second level of message broker that brings the data in the central SOGNO platform in the control center. So in that respect, the solution not only is modular, but it can also be organized to be fully scalable, so that it fulfills the requirements of broad, large distribution grids. What is important is that was not just a theoretical activity, but was accompanied by a clear field test. So the software being tested in real field tests and real grids. So you can see here the variety in Ireland, in Romania, in Germany, and also in Estonia. In all of them, we had the possibility to connect to real devices and to embed the SOGNO solution in a real network operation, showing that is not an academic exercise, but is just something very close to deployment in commercial sense. And then thanks to the results, we moved to another project that is currently running. SOGNO ended last year. Platone is like the child, with the idea to expand the view and to bring more experience in field test. And this will run until 2023, and having 12 partners from Belgium, Germany, and Greece, and Italy working together and bringing the results into demonstrations. What is interesting here, that what we call SOGNO platform in this diagram is basically the green box that you see here, which is generally speaking here identified as a DSO platform. What is added here is a set of interface that make the system multi-layer. On one hand, the possibility of a thin layer blockchain base to allow trust between data coming from the customers into the system. This is multiple use. On one end, the possibility for data coming from the customer to become part of the operation. So you need this trust mechanism, in this case, this blockchain solution, but also the blockchain architecture can support peer-to-peer market between customers, among customers, so that you support really a customer-driven type of market, local energy market. The other important interface newly developed here is the link between the DSO platforms and market platforms. Trying to be as abstract as possible, so not a specific market platform, but developing standard API so that this system altogether, bringing the three pieces together, offers a full solution for flexibility management at DSO level. And so that's basically the idea. What this new level of interfaces is bringing is the capability of integrating legacy solution on one hand, and on the other hand, the possibility to really empower customer to become part of the active management of the grid through flexibility markets in particular. And here we see the platform in a slightly different view, where you really see these key interfaces even more clearly. In the middle, the DSO technical platform, that is what is now the core of the SOGNO LFE project, and the three key interface market that I mentioned, the blockchain interface for data interface from the customers, and very important, I want to stress it again, the link to the legacy system. While we don't see this platform as coming and fully substituting standard solution, the control room, SCADA solution, and so on, but like an extension, flexible extension that allows a grid operator to use their legacy system and to expand and explore new services in a flexible way in this microservice architecture. How much will be in which? This is a question of the future. So we may imagine beginning mostly to be legacy system and few service to run on the SOGNO platform. And we can imagine in the future people to exploit more and more the flexibility of the openness of the DSO technical platform or SOGNO platform. Even here, we are not talking about theoretical development, but testing in three large demo. Again, one in the north of Germany, where it's mostly supporting local consumption through a DSO, helping the optimization of the local consumption, a full flexibility market analysis in the city of Rome, in a very large demo in the capital city of Italy, and a more distribution system management oriented demo in Greece. Again, exploiting flexibility, but also having a clear focus on advanced network observability. So again, three large demos that will bring us a lot of knowledge and new components to enrich the platform. Parallel, another project is using the SOGNO platform right now to develop a concept of advanced virtual power plant, we could call it virtual power plant 2.0, in which the virtual power plant is closer to the distribution grid operator, facilitating new family of services, and again, having this SOGNO platform in the middle as the data gateway that facilitates the implementation of these services. Thanks to this new concept, we'll explore new solution again in the flexibility market and different standards like the GoFlex standard, but also the new services that we didn't have before, voltage control as a local service, and services that the DSO through the platform can aggregate and support the TSO, like inertia estimation or inertia response control for a low inertia grid type of situations, in supporting then the TSO in the task of frequency control. As all the other cases, we are talking about something with clear demos. Apart from the list of partners, we have some demos of the different service running in Germany, 2 times in Germany, one for the slow dynamics, one for the new type of services, what we call fast dynamic services, and a full laboratory test running in Aachen. And then there will be a set of trial related to the fast dynamics running in the region of Bologna in Italy. In conclusion about the so-called history of SOGNO, I'd like to mention that another important point of development that is enabled by the flexibility and openness of the concept is the link between the, not only to the third party or legacy as you saw before, but as you see on the right side, the interest to bring this concept into a large data platform. So providing, thanks to an IoT agent, a links to the context broker, which is the core of the Fiverr platform. The Fiverr platform is a very successful platform in the smart city scenario. And what we want to enable here is to encapsulate, let's say, the SOGNO solution into the Fiverr architecture to support multi-energy scenarios, but also even beyond, and bringing energy to be one open vertical in the concept of smart city. With that, I conclude this first part of the presentation, the history, and now I give words for the second part to my colleague, Markus Mirz.
Thank you, Professor Monti. My name is Markus Mirz, and I'm going to present the main concept of SOGNO, examples, and the next steps of the project. As Professor Monti already mentioned, SOGNO is about developing automation functions as cloud-native microservices to facilitate scalability and the rapid adoption of these automation functions. The services communicate via common protocols like HTTP or messaging protocols like MQTT. And we try to use existing standard data models as much as possible, like SIM or the European version CGMES. Another key feature of SOGNO is the real-time simulation support that lets you try automation functions for rapid prototyping and testing without putting real equipment at risk, because the real-time simulator mimics the real system. So what does SOGNO provide? When you go to the GitHub organization, you will find a catalog of services like state estimation, voltage control, and also the real-time simulator and packaging for these services, Docker images, and also Helm charts to easily deploy them to in Kubernetes environment. There are also example configurations that put different services together, and I will show you one in the next few slides. And then there's also documentation on how to set up a small Kubernetes cluster using K3S, for example, and then deploy the examples. So what I want to show as an example here is state estimation. State estimation lets you estimate the complete state of your system from few measurements and your network topology information. So you might not have available all the node voltages of your system that you need for other services like voltage control and contingency analysis. State estimation can estimate these node voltages and also branch currents from few measurements that you have from your system. How does this look like in terms of SOGNO components? We have a real-time simulation here that for this example provides some virtual measurements and pushes them into the message broker. And there's the state estimation algorithm that takes the measurements from the real-time simulator and computes the estimates. All of this is stored in a time series database and then visualized using Grafana. And there's also a sim grid viewer to visualize the network that we are simulating in the real-time simulator. Eventually, this real-time simulator could be replaced by real measurement devices if you want to deploy this algorithm in the field. So let's have a look at the video. You could run these commands in a script, but here we splitted them up so that you can see the process. First, we install the Helm repository of SOGNO, and then you can install different base components like RabbitMQ, Telegraph, InfluxDB, and here the next one is Pintura, the sim editor that you will see next. So you can go to your browser, select some XML sim files, and they are rendered by Pintura. In this diagram, you can click on components and see the parameters, or you can also go to the list of components. And then in this case, the list of line segments where you find the parameters of this line, for example. Next, we are going to install Grafana and also a predefined dashboard for this demo. So going back to the browser, and also the real-time simulation, of course. Going back to the browser, you can see the predefined dashboard and already some results coming in from the real-time simulation. In this case, for node 2 and 11 of the SIGRE medium voltage grid that we just presented in Pintura. So these virtual measurements are coming from the real-time simulator. And now we install the state estimation package. So after updating the page, you can view not just the measurements coming from the real-time simulator, but also the estimates coming from the state estimator in yellow for node 2 and node 11. So this completes this example. Coming back to the slides. The next thing that we would like to approach in SOGNO is the integration of voltage control with the state estimator, as I described before. Voltage control can be applied, for example, in distribution grids, where you can see an overvoltage due to increasing power generation or an undervoltage due to increased load consumption. In this case, you can use the results of the state estimation, for example, your node voltages, and control devices like PV generation or battery storages. In this particular example here, we are using a coordinated control approach with PV generation units. And it's coordinated because not just the PV generation that sees the problem here is activated, but also other PV generation units on the feeder. And the priority is reactive power control here. Only if this is not sufficient, active power is curtailed. So let's go to the video. Here you can see, again, a Grafana dashboard. And this is not running in Kubernetes. This is just to show a voltage control algorithm. Here you can see in blue the voltage limit and also the node voltages. They are all above the limit, so we need to do something. Now we activate the voltage control, and you can see immediately the voltage is going down using reactive power capability of the PV generation units in this case. However, the reactive power capability is not sufficient, so we need to curtail the active power. And this is done in the next step. I skip forward a little bit. Here you can see the result. Okay, so the current roadmap is to integrate the voltage control that I just showed with the Kubernetes example of state estimation. We also have a time series prediction Python package that we would like to use as part of the voltage control. We are working on the HTTP APIs and the Open API specification of the services that I already mentioned, so that once they are deployed to Kubernetes, they can be configured using the HTTP API. And the last item on the roadmap is very important, the integration of the Fledge Linux Foundation project, which allows us to support multiple industrial protocols like IEC 104 and IEC 61850 out of the box. And with this, I conclude my presentation. Thank you.
So I guess now it's time for us to look at the questions in the chat. So we'll start in the order I've seen coming. First one says, is Platone contributing to the LF Energy SOGNO project? What I can say that for sure, everything developed by RWTH ported to the Linux Foundation. We are discussing with the companies that are involved, and I'm quite optimistic that basically, because everything that we do in the Platone is open source, that will be possible to bring the overall solutions that we implemented in Platone as a contribution to the SOGNO project. So in a short, I will say yes, that's the plan. I cannot promise everything because some companies still have to give us the full agreement. Then the second question.
Sorry, you can hear me, okay. I just wanted to further elaborate this question. So actually there are already some concrete outcomes of Platone that made it into SOGNO. The Helm charts repository and all of this packaging that is developed in the frame of Platone. And the voltage control that is going to be integrated with the example is an outcome of the EdgeFlex project. So basically all the projects that Professor Monti described before are already actively contributing to the Linux Foundation project.
Thank you, Markus. Second is about SOGNO vehicle to extend the lifetime of the H2020 developed technology. I would put it the other way around. SOGNO is a vision, and we use the funding of the Horizon 2020 to continue developing the vision. And we see the Linux Foundation as the long-term view and the way to transfer from a project to a platform where we can cooperate together. So that's the way I would frame it. Concerning the link between SOGNO and VILAS, well, VILAS framework is another large project of my institute. It stands for Virtual Integrated Laboratory for Large System Simulation. So VILAS is about integration of labs and data exchange to build complex experiments. The SOGNO platform fits and interfaces to the VILAS framework. Actually, in the first test of the SOGNO project, we were linking to the VILAS framework to perform our test. But they are two separate activities. Because they come from my group, of course, they work very well together, but they have different tasks. So SOGNO is grid automation. VILAS is about interconnection of remote infrastructure, typically laboratory. And so of course you can use them together, but they are two separate activities that we are covering different projects. Do we
actually?
Yeah, no, good, please, Markus.
So on the VILAS framework, actually in the video that you just saw where there were MQTT messages coming from the real-time simulator, these messages are coming from DPSIM through the VILAS node, which is part of the VILAS framework, to the message broker. So it was used in the video that you just saw.
Oh, that's a good point. Do you have any partner in Spain? We work with Spain in other projects, not specifically here. We have a good cooperation at the university level with Comillas. But we are, of course, open to cooperation with Spain. Then next question, how can I implement the SOGNO project in my personal lab? I think just you need some Linux machines and install the containers as Markus showed. So if you visit the GitHub, you will find the instruction. Maybe Markus, you want to add?
Yeah, when you go to the LF Energy page of SOGNO, there's a link to the website, and this website has the documentation, and it describes on how you set up K3S on an Ubuntu Linux machine, and then install install using Helm the different components. And this is continuously growing. So the more that we add services, the more we also add description of how to install them using Helm.
Then there is a question, would it be possible to use SOGNO for micro nanogrids? Well, in principle, yes, as architecture, there is nothing wrong to use it also for nanogrid. At the end, we mentioned this project Platone. What the grid operator there is treating their low voltage network as a microgrid. So they are not officially microgrid, but it is the low voltage covering a small village in Germany. And the grid operator is managing the interface like a microgrid. So in principle, it's not being started as a microgrid controller, but microgrid controller can be a service that you run in this architecture. What's the best location for running that service? Is telecom operator edge an option? Definitely. This was one of the business model in SOGNO. If you look in the website of the SOGNO project as Horizon 2020, you will find some business case analysis. And for sure, particularly going in the 5G infrastructure, that was the original idea. The telecom operator could offer the automation as a service running on the edge cloud, which is one of the key components of the 5G architecture. And this will be a very typical way of doing it. This could be a private network that, for example, the grid operator buys from the telecom operator. This is a setup we are also investigating, hopefully, with an upcoming project in Germany, which a cooperation between Ericsson and a grid operator will allow the use of local edge cloud in the 5G network to establish a distributed intelligence for grid automation at DSO level. How is the communication between the DSO and the TSO realized? In the current demos where we are doing this is in the project Platone, we are using that kind. The communication comes through the market interface. So the SOGNO platform collect in the market platform the flexibility request from TSOs, and then is also collecting the offer from the customer. So is somehow the glue in the middle between data coming from the customers and requests coming from the TSO. The link there depends on what market platform is used. And in Platone, we are using for the moment a market platform developed by our partner engineering as an open source as well. There could be other versions that will be also hopefully considered in the evolution of Platone in the next couple of years. So that's still under implementation right now, I would say. For the next question, does SOGNO relate to other projects like Reacts, GFX, and operator fabrics? I think this is an exercise, Markus maybe can add more, but that's an exercise we are doing right now that is inside the foundation, trying to understand how to better use each other, let's say. So how to align the projects and build synergies among the different initiatives that started as a bottom-up, and now it's kind of like the time to align and build synergies among those different. But this is, I would say, work in progress. For the next one, maybe Markus, you're more aware what was the requirement of the voltage control that was in the demo. Are you aware of the data rate? I think is about 1 second.
Yeah, and the control messages are exchanged using MQTT. Okay. And for the previous question, so at the moment we don't plan to work on any kind of user interface. We have Grafana, and we have for the SIM viewer, but that's it. And in the roadmap, as you can see, there's nothing in this direction. So one idea would be to use operator fabric as the UI. Yeah, that's one idea. GXF, I guess, is also for somehow data aggregation. I think maybe going a little bit in the direction of Fletch. Re-ups, from the top of my head, I'm not sure exactly how this relates, but yeah, it's something, as Professor Monti said, that we are discussing right now.
Okay, next question. I don't know how much time do we have. I guess we're close to be over time, so we'll try quickly to answer everybody. So do you use ready-made software like Kafka for the message broker component, or did you roll your own? We use software already made, right?
Yeah. So we use RabbitMQ when it comes to MQTT. And for Kafka, we had the problem, we looked at this some time ago, and the problem was this Kafka operator, which is licensed under the special Confluence license. Now we are looking at a project that's called Strimzi, I hope that's correctly pronounced, that provides exactly this functionality, but using Apache license. And yeah, so we are not developing this part ourselves.
Then there will be guidelines to develop microservices of control or other real-time application that can interpret and be tested in the SOGNO platform. Yeah, this is the main task of the technical working group leading the project. So Markus is doing this job. So yes, if you join the foundation and then participate in the SOGNO project, you will be cooperating on defining these guidelines. Last question looks like, do you have any partner in Canada? Yes, the University of Alberta is working very closely with us, is officially, because of a transnational cooperation, or the European Commission is officially involved in the project Platone. So we have a very close cooperation with Professor Muslek in University of Alberta, and also with the local university connected to University of Alberta, which is running a test site on microgrids. So going back to the previous question, and so we will expand our use cases and analysis in Canada in cooperation with mostly key partner, University of Alberta at the moment. I think we answered all the questions, and really thankful for this very interesting list of questions. I hope you find the presentation interesting. We are very happy to have more people that want to be active in the SOGNO project, which is really, really young. And but like I said, because we have a history of project behind, projects that are also upcoming, I think there will be a lot of material that will flow into this vision that I think has a lot of potential to transform distribution grid automation. Thank you again for joining our presentation. Have a nice rest of summit, and hopefully we'll see each other in one of the future meetings of the SOGNO project. Bye-bye.
Thank you,
Markus.
Bye.